Hi, I'm Miss Hearn. Let's get started.
What did we say was the rule? A conjunction is only true if both parts are true. The second extremely important rule that you need to make a note of. Disjunction is only false if both parts are false. Another connective that we learned about in section 3.1 is the negation. The negation of a statement has the exact opposite truth values of the original statement. So the original statement only has two possible truth values. The component is either true or it's false. So either the original statement P was true, which would mean that the negation is false, or the original statement was false, which would mean that the the negation of it would be
true.
So what we're going to do now is we're going to use the negations together with the ands and the ors. We're going to determine the truth value of these compound statements, and we're going to work it out just one step at a time. When I'm working out the problem here, I want you to pay attention not only to the answer, but also to the way that I'm working out the steps of the problem, because I'm trying to model for you what I think will work best so that you have the most success. Looking at this, let P represent the statement 4 is greater than 1. Let Q represent the statement 12 is less than 9. And let R represent the statement 0 is less than 1. Decide whether each statement is true or false. Okay, so I'm going to make a little note to myself about the truth value component, and then we'll come and analyze these compound statements. So what do you think? What's the truth value of P? That's right, 4 is greater than 1, so P is true. What's the truth value of Q? Q is 12 is less than 9. Is that true or false? That's right, Q is false. And how about R? 0 is less than 1. That's true. Okay. So for part A, I'm going to write out negation P. What's this symbol? How do I read that out loud? And. Very good. So we have negation P and negation Q. Or probably I would generally read this as not P and not Q. So now what do we do after we write out the statement? We replace each component with its truth value. So I'm going to write negation, and then I'm just going to replace the P with the true, and negation, and replace the Q with what its truth value was, which was false in this case. That's going to vary from problem to problem. Now I'm going to analyze the negations. There's a certain order of operations that happens just like in algebra. Remember how in algebra you do what's inside the parentheses first, and then you have the PEMDAS, so parentheses, exponents, multiplication and division, addition and subtraction. So there's a particular order, accepted order, that's implied. Well, there's the same type of thing here. First of all, any negations of individual components, we're going to prioritize. So when I say that, I'm talking about, for example, not true right here. That's a negation of an individual component. And also not false over here. Okay, so what is the negation of a true statement going to be? That's right, the negation of a true statement is going to be false. And what's the negation of a false statement going to be? It's going to be true. That's right. So now we have a statement that's equivalent to the previous line, false and true. Okay, so now we're going to analyze that remaining. There's only one logical connective left, that's the and. What's the rule for and, for the conjunction? An and statement is only what if what. Pull out that note card or wherever you wrote that down. Yeah, and statement is only true if both components are true. So do we have both components true here? No, we don't. So then the only other alternative is it's false. And that is the truth value of the statement we were given. Okay, so that's part A. Any questions about part A or anything you'd like me to repeat? All right, that's part A that we just worked out. Now let's look at part B. For part B, we have the negation of P, and then what's that V symbol really mean? Or, good, and then R. Okay, we're still using that P is true, Q is false, and R is true. what should I do first? Imitating what I did in the previous problem, what should I do? What did I do to get from this step to this step? Yes, replace each component with its truth value. That's right. So in this case, what should I write? Remember, both P and R were true statements. So we're going to replace this with not true or true. Okay, now what do I deal with first? The negation symbol or the or? That's right. Negations of individual components are prioritized. So we're going to start there. So the negation of a true is a false. So I have replaced the not true here. I replaced it with false. Now I'm down to just one connective to analyze, which is the or statement. And what's the rule for or? Only what if what? Only false if both are false. Excellent. So then what should I write for the final answer here? True. Very good. False or true is true. Okay, now let's look at part C. Part C was the negation of parenthesis P or R. Now, just like in algebra, the parenthesis changes the order. I'm not going to do negation P because that negation is affecting whatever is inside of the parentheses. We have to work inside the parentheses first. Okay, but before we do that, we have to replace each component with its truth value. So P and R are both true, so I'm going to replace them with T's. So now I've copied down the negation symbol in the parentheses and the or, that all stays the same. All I've done is replace P and R with their truth values that we were given at the beginning. All right, so now we have negation of parentheses true or true. Since we're working inside the parentheses first, we need to use the rule for or. We said that the rule for or is only false if both are false. Well, we don't have both false. In fact, they're both true. So I'm going to replace true or true with what? Good guess, but no. Just ignore. I think you're thinking of the negation out here. We do not work with that yet. You have to ignore it for a minute. We're focusing inside the parentheses. So if I just gave you true or true, what would you write down? True or true is false? True or true is true. That's right. So what we're going to do is we're going to write down negation. I'm still carrying down that negation from the previous step there. And then instead of the parentheses, I just have a single true. True or true is true. All right, but then we need the negation of that result. That's what that negation outside the parentheses is telling us, is to negate what's the result of the operation inside the parentheses. So yes, Rashad, that's going to be false. The negation of a true is a false. Okay, so what we saw there was the order of operations in logic. First, work on negations of individual component. Then work inside parentheses takes priority. And we didn't really have to get into this because we didn't have enough connectives strung together. But in general, if you have a bunch of them, you're going to work from left to right, as long as parentheses aren't telling you to do otherwise. Okay, so this is also something you might want to make a note of, the order of operations in logic.
I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.